Vectors 9.5 intersection of three planes. How will you interpret the solution to the following systems geometrically? So we are given three reduced matrices, and that is at the stage when you simplify the matrix adopting elementary row operations. Now in the first one, you notice that there are triangular zeros here, right? So that clearly indicates that the three planes intersect at a point. Now in B, what you notice is that the two rows are zeros equals to 0, so 0 equals to 0. So that means they are common, right? So that means all the three planes intersect. So every line indicates one parameter. So we got two parameters, and an object with two parameters is a plane. So the three planes intersect in just one plane. That means they are the same planes. In the last case, what you notice is that you got 0, 0, 0, and you get 0 equals to 1, which is not possible. So this is not a solution. The system is inconsistent in this place. And what really happens here is that the two planes will intersect in a line, but the third plane seems to be parallel to the intersection of that line. So I'll draw you and show you how geometrically it should look like. So let's start with the very first one. So in this one, what you notice is that you get these set of zeros, correct? So now, since you get these set of zeros, you can get the x value as 3x equals to minus 12, and you get a point, which is x equals to minus 4. And when you plug in x equals to minus 4, then you can find y and then z. So you get a point here. So in this particular plane, what we really get is that the three planes intersect at a point. Imagine like this, it's a coordinate system, x, y, z plane, and the origin is kind of like that. Now let me draw and show you how it should look like, right? So let's say this is one of the planes. So this is one plane. So I'll draw three planes in three different colors. In that case, it'd be simpler for us to imagine. So we have the other plane which intersects this plane in a line, for example, right? So this plane kind of comes like this. So so we'll just draw a line here and a line there. So it is kind of like this and a line there, right? So this is the second plane which crosses it like this. But the third plane goes through it in a way that, like imagine like it's going from here inside into the paper, kind of like this, bisecting or just getting into it in this fashion. So intersecting at a particular point, right? So imagine this is the plane which is just getting into it, right? So we'll just draw this, and so that is the plane which is getting into this, just so slicing it from the center. So there is a point of intersection. So that is how you can draw and show these three planes intersecting at a point. So in this particular case, what we see is that the system is consistent, right? And there is a point of intersection. So the three planes intersect at a point. And one more thing what you will observe here is that if you do the scalar triple product of the normals, then it won't be equal to 0. So that's another very important thing to note. That means n1 dot n2 cross n3 is not equal to 0 for this particular case. Now let's take the second example. Now here the last row indicates that 0 equals to 0 is perfectly fine. That gives rise to one parameter. The next row is also 0 equals to 0. That means another parameter. So the object has two parameters. So the object has to be a plane. So it's a defined plane for us, right? So that is the normal for our plane. And the equation is like x minus y plus z equals to 4. So that is the equation of your plane. So basically, in this particular case, what we have is three different planes, and all are exactly the same planes actually. So we have three planes which are kind of same, right? So we'll just draw these three planes. in different inks, and so that is what we really get. So in this particular case, what you'll observe is their normals are scalar multiples, right? So here in this case, n1 equals to k times n2. You can say k1 times, right? And n3 is scalar multiple k2 times n3, right? Somehow they are all scalar multiples of one another, correct? So that is what you'll observe in this particular case. Now the third case indicates that, of course, this is a consistent system, right? So this system is also consistent. Since every point in the plane is a solution, right? And plane is itself intersection of itself, right? So all the three planes overlap. Now in this particular case, this system is inconsistent since there is no particular solution. So I'll write inconsistent first. Now here, what we observe is that if we have two planes, then two planes will intersect in a line, right? So let's say we have these two planes, right? So these two planes will actually intersect in a line, and let us say they intersect in this line, and then we have a plane here, right? So they are intersecting in a line, and the third plane actually intersects two planes separately, right? So they don't really intersect in one particular line, but they intersect separately. And what you'll observe in this case is that the third plane will actually kind of like this, but they're normals. This plane will be parallel to the line of intersection, and that is, they'll form kind of a triangular prism right there on the top. So that thing which you see on the top is the triangular prism which will be observed in this particular case. You see that part. So that kind of a triangular prism will be formed. So I could have joined this right, like this, right? So that triangular prism will be formed. In this particular condition, you will observe that all the normals are actually equal to 0. So scalar triple product in this case, n1 dot n2 cross n3 will be equal to 0. All normals are in one plane, right? So that is kind of the observation which you will make once you get this kind of solution, right? So I hope you understand now, when you get this kind of a geometric, the algebraic solution in the form of matrix, then geometrically the planes will look like I've shown, right? So we'll have one more video to cover up for other cases also, right? So in this way I'll cover about 6 cases with you and go through them nicely so that you understand what is happening in this section when 3 planes intersect and how to connect algebraically or algebraic solutions with their geometric position. I hope you find it interesting and extremely useful. Thank you.